Okay. So can you able to see my screen? Am I visible and audible? Just let me know in the chat box, students. Just tell me whether am I visible and audible to you, and the screen is visible. Or... Yes. Okay. Then just wait. Let's just wait for 1 or 2 minutes and then start the class. Okay. So the 12th class students who have joined here is from which school? May I know the name of the school? Is this a group of students sitting over there behind the screen or a single student? JMB Vishakhapatnam. Okay, okay. Okay, then. I think we can start the class now. So we were discussing about the aldehydes, ketones, and carboxylic acids, right? So let's continue the same lesson today. So before moving on to the today's session, let me recall the previous class with a question. And can you find out what is the name of the product in the addition of HCN to carbonyl group? So we have got a carbonyl group and HCN is getting added to it. And finally, we are getting a tetrahedral intermediate kind of compound. And can you just tell me the name of the compound that is being formed? So what is the name of the intermediate product that is being formed here? Just take 10 to 15 seconds and try to answer for this question. So in the last class, we were discussing about the nucleophilic addition reactions and oxidation and reduction, right? So in nucleophilic addition, we have discussed this reaction. This was the first reaction we have discussed. JNB Vishakhapatnam students, just let me know in the chat box the name of the product. Okay. So the name of the product is cyanohydrin. Okay. So this is cyanohydrin basically. And now coming to today's class. So today we are going to continue the chemical properties of aldehydes and ketones. We have 6 chemical reactions, and out of 6 we have discussed only 3 in the last class. And today we are going to discuss the remaining 3 and then the uses of aldehydes and ketones. Okay. So moving on to the chemical properties of aldehydes and ketones. The fourth reaction, that is the first reaction for today, is reactions due to acidity of alpha hydrogen. Okay. So let me discuss about the acidity first. So this is the RC double bond O CH3 group. This is the RC double bond O CH3 group, which is the ketone here. Or if the R group is hydrogen, then it is called as aldehyde. Okay. So see here, and the carbonyl carbon is here. This is the carbonyl carbon, And the carbon which is next to the carbonyl carbon is called as alpha carbon. And the hydrogens which are attached to those alpha carbons, they are called as alpha hydrogens. And those alpha hydrogens, so this is one of the alpha hydrogen. And all the three alpha hydrogens are acidic in nature. All the three alpha hydrogens are acidic in nature. Okay. So now talking about the aldehydes and ketones. So aldehydes are having pKa value of 17 and the ketones are having pKa value 20. Now pKa is inversely proportional to acidity. pKa is inversely proportional to acidity. So the one which is having higher pKa value is least acidic, or the one which is having lower pKa value is more acidic in nature. Now you see here, aldehydes having pKa value of 17, which is less than ketone. Since it is having lesser pKa value, aldehydes are more acidic than ketones. Aldehydes are more acidic than ketones. Got it? Or we can say ketone is less acidic due to the presence of plus I group. What is plus I group? Positive inductive group. They are electron donating groups. Since we have two electron donating groups in the ketonic part, the electron density on the carbonyl carbon increases, so acidity decreases. So ketonic carbonyl carbon is less acidic and the aldehyde carbonyl system is more acidic in nature. Got it? Is the acidity concept clear to you? If it is clear, just type yes in the chat box, or it is clear in the chat box so that I'll understand that you are listening and the concept is clear to you. So 2 more students have joined now. So let me just quickly recall the thing which I have discussed. So the carbon which is next to the carbonyl carbon, yes, thank you students. And the carbon which is next to the carbonyl carbon is alpha carbon, and the hydrogens which are attached to the alpha carbon, they are called as alpha hydrogens, and those alpha hydrogens are acidic in nature. And comparing the alpha hydrogens of aldehydes and ketones, so aldehydes are more acidic than ketones. Okay. So this is what we were discussing and it is clear to you. Let me move on to the next concept. Okay. So based on this alpha hydrogen, we are going to see few reactions which are occurring due to the alpha hydrogen part. The first one is iodoform reaction. So this is the reaction, that is the RC double bond O CH3 group, that is the ketone part. When it reacts with iodine in presence of sodium hydroxide, it forms RC double bond O ONA, and it forms a yellow precipitate which is called as iodoform of formula CHI3. Okay. So what is happening here? On treatment of this compound with iodine and NaOH, the CH3 group which is attached to C double bond O, it is getting converted to ONA. So how do we come to know that the reaction gets over, or we are getting RC double bond O ONA? Just by seeing the yellow precipitate in the container. That yellow precipitate is due to the formation of iodoform. CHI3 is iodoform. Okay. And it is used as a test for methyl group in the carbonyl compounds, because methyl groups are converted to ONA, right? So it is used as a test for methyl groups in carbonyl compounds. Okay. And alcohols also respond to this test. What type of alcohols respond to this test? CH3, CH2OH and isopropyl alcohol, that is CH3, CHOH, CH3, means CH3, CH, OH and a bond. So the alcohols which contain this group will respond to iodoform test. Okay. From iodoform test, we get yellow precipitate if the reactant contains CH3, CHOH group and or if the reactant contains CH3, C double bond O group. Okay. Got it? So here in this alcohol you see CH3, CH, OH And in the fourth part also we are having hydrogen. So this is the part group present in ethanol. And in case of second alcohol, CH3, CHOH and CH3 group is there. So here also we are having the part or the group which is used to form the CHI3, yellow precipitate. Got it? Is the reaction clear to all of you? So the system contains these two groups will give positive test for iodoform reaction. Got it? And the color of the precipitate is yellow. So these two informations are very important. Okay. Shall we test the concept which we have discussed now? So give simple chemical test to distinguish between the following pair of compounds. That is, you have to distinguish between pentan 2-one and pentan 3-one. So which test we have to use? Just now we have seen iodoform test we have to use. So what is pentan 2-one? This is the formula for pentan 2-one. It is 1, 2, 3, 4, 5. This is pentan 2-one. And in pentan 2-one, we have CH3 C double bond O group. And this NaOI has come from iodine and NaOH, which we have seen in the previous slide. So this NaOI has formed from this. And on treatment with this, we are getting C double bond O, ONA with the release of CHI3. Okay. But in case of pentan 3-one, we do not get the iodoform. Why do we don't get the iodoform? So the formula for pentan 3-one is CH3, CH2, C double bond O, CH2, CH3. So you see here, we don't have CH3, C double bond O group. Instead of this group, we have CH3, CH2, C double bond O. So this group will not respond to iodoform test. So only the system which contains the methyl ketone will respond to iodoform test, and that's why pentan 2-one is forming the yellow precipitate while pentan 3-one doesn't form the yellow precipitate. Okay, got it clear? Students, is the concept clear to you? Shall I move on to the next reaction? Just let me know in the chat box if it is clear. It's not clear? Okay, listen. Is the question not clear to you or the concept is not clear? See, question is not clear. Okay. So see the question once again. So you have to give a simple chemical test to distinguish pentan 2-one and pentan 3-one. Okay. So let me write the structure of pentan 2-one. So the structure is CH3, CH2, CH2, C double bond O, CH3. So pent means 5 carbon, right? So 5 carbon I have written, and in the second carbon I have a ketone group. So this is pentan 3-one. And this pentan 2-one and pentan 3-one can be distinguished using the iodoform reaction, because iodoform reaction gives positive result only for the compounds which have CH3 C double bond O group. That is when the compound contains methyl ketone group. Okay. So that's why pentan 2-one is giving the positive result, since it contains C double bond O CH3 group. Okay. And in the reaction, what happens? The CH3 will be in presence of I2 and NaOH. CH3 will be converted to CH3, CH2, CH2, C double bond O, ONA. This is what we have seen in the previous slide, right? So pentan 2-one is giving the positive result for iodoform. We get CHI3 also, and it is formed as a yellow precipitate. Okay. Whereas In case of pentan 3-one, what is the formula for pentan 3-one? So again the 5-carbon containing system, but C double bond O in the third position, third carbon. Okay, so this is 1, 2, 3, 4, 5. This is pentan 3-one. Okay, and this pentan 3-one on treatment with I2 and NaOH, we will not arrive at CHI3 or will not arrive at this kind of product, because pentan 3-one doesn't contain methyl ketone. Instead of methyl ketone, it contains ethyl ketone. It contains ethyl ketone. So that's why we do not get iodoform in the product side, and because of that, yellow precipitate is not formed in the reaction mixture. Since there is no color change in the reaction mixture, we can identify that the system is having pentan 2-one and it is not pentan 3-one. This is how you can distinguish both the compounds. Is this clear now? JNB Vishakhapatnam, is this clear now? Students, is this clear? Okay. Okay. I'll move on to the next reaction, which is called as aldol condensation. Okay. Aldol condensation is also due to the acidity of alpha hydrogen only. It is also one of the reaction due to alpha hydrogen. So this is the reaction. In the reaction, we are taking 2 moles of aldehyde. Okay, 2 moles of some aldehyde which contains alpha hydrogen. So who is the alpha hydrogen here? So this is the carbonyl carbon, and this is the carbon which is next to the carbonyl carbon, means this is the alpha carbon, and the hydrogens which are attached to the alpha carbon, they are called as alpha hydrogen. So how many alpha hydrogen we are having here? 2 alpha hydrogen we are having. Okay, and we are going to treat this compound with KOH or NaOH. That is, you are going to treat the compound with the base. Okay, on treatment with the base, the 2 moles of the aldehyde is forming an aldol. So what is aldol? Aldehyde and alcohol containing system is called as aldol. Okay, and then this aldol on heating forms an alpha beta unsaturated carbonyl compound. So what is unsaturated? Unsaturated means double bond or triple bond system. Okay, so it is alpha beta. So this carbon is alpha carbon and this is the beta carbon. So it is alpha beta double bonded system. So it is called as unsaturated carbonyl compound. Okay, so this is the aldol condensation. Instead of forming this aldol, you can straight away get the product from the reactant just by using this trick. So what you do, first you take the first mole of aldehyde and then you take the second mole of aldehyde, remove the water molecule like this. Remove the water molecule like this. So what you are doing basically, we are removing the oxygen from the first aldehyde and the alpha hydrogens from the second aldehyde. Okay, and the removal of water leads to the product, final product. You see here, we are removing this water and connect this double bond to this alpha carbon so that you will get the final product here. Okay, this is the aldol condensation product which forms by the elimination of water. Is this clear? Or I'll give you an example. Let us take this aldehyde as CH3 CHO. So we are going to take 2 moles of CH3 CHO. So what is the product we get from this thing? So let me draw the 2 structures separately. So it is CH3 and C double bond OH. So this is the first aldehyde. Or I'll write the double bond like this for your better understanding. Wait just a second. So I'll write the double bond here. double bond O and H. So this is the first mole of CH3CHO, and this is the second mole, that is CH3 C double bond OH. This is the second mole of ethanol, that is acetaldehyde. Okay. Now we are going to add these two compounds. So what we are going to get at the end? Remove the oxygen from the first aldehyde and remove the alpha hydrogens from the second aldehyde. So who are the alpha hydrogen? This is the carbonyl carbon and this is the adjacent carbon, which is alpha. So these three hydrogens are alpha hydrogen. So what we have to do? Remove two hydrogens from the alpha carbon. That is, we are removing the water molecule and connect the carbon, aldehyde carbon, to the alpha carbon here. So what you will get at the end? CH3 is there. This is the CH3 part and it is connected with CH, then double bond. Then double bond is connected to which carbon? This alpha carbon. This alpha carbon. That is the carbon from which you are removing the hydrogen. Okay. Carbon is there and one more hydrogen is there, no? So that is this one. And here C double bond OH, that I'll write as CHO. Okay. This is the final product from the given ethanol. Okay. What is the name of this compound? We have to start from the aldehyde, right? So 1, 2, 3, 4. So 4 carbon containing system. So it is called as bute. And between second and third carbon, we are having a double bond. So bute 2E. And in the first carbon, we are having the aldehyde. So it is ene 2E 1-al. Or you can write this as bute 2-ene-al also. Okay. Got it? Is the aldol condensation reaction clear to all of you? Just type yes if it is clear or type no if it is not clear. Okay. Thank you so much for your response. Then I'll move on to a question for you. Just a previous year question. Okay. So consider the given reaction. The functional groups present in compound X are. So what is a functional group present in X? So you can go through this reaction again. See, this is the compound X which we are getting. So in that compound, we are having an aldehyde and an alcohol part. Okay. So here in the reactant, instead of aldehyde, they have given ketone. Whatever might be the compound, it can be an aldehyde or it can be a ketone. Ketone also contains alpha hydrogens, right? So the reaction occurs there. And before the final product, a compound X forms. And that compound X has an alcohol part. Yeah, alcohol part and a ketone part. Very good. Very good, students. So option D is the correct answer. Okay. So you have to see very clearly. You should not just pick this answer. There is a chance of selecting option C. Okay. You have to see the reactant properly and then you have to select the correct answer, which is D here. Okay. Okay, fine. Then next we'll go for cross-aldol condensation. So when aldol condensation is carried out between two different aldehydes or ketones, it is called as cross-aldol. So in the previous reaction, I took 2 moles of the same aldehyde or 2 moles of the same ketone. But if you take two different aldehydes, that is, if you take one ethanol and one propanol, they are different aldehydes, no? In that case, we arrive at the cross-aldol condensation product. Okay. If both of the aldehyde or if both of the ketone contain alpha hydrogen, then the particular system gives 4 products. Okay. Let us see those 4 products. So I took 2 different types of aldehyde. So this is 2 carbon containing aldehyde, which is called as ethanol. And this is a 3 carbon containing aldehyde, which is called as propanol. Okay. So these two are going to react with each other and they are going to form 4 products. So in basic medium, the first mole of acetaldehyde reacts with the second mole of acetaldehyde or ethanol. Okay. So listen. So 2 moles of ethanol first forms a product. So this is the product we get from the reaction of 2 moles of ethanol. Just now we have prepared this, no, the but2-enal from 2 moles of acetaldehyde. This is just the same product. Okay. So this is the first product. And secondly, 2 moles of propanol reacts to give the second product. Okay. So this is the carbanion, and this carbanion attacks this carbonyl carbon and it forms the second product. You don't have to worry about the charges and all. Just do the trick which I have said and you will get the product. Okay, so what is the trick? If I'm going to react these two compounds, just take the first compound, CH3, CH2, CH3, CH2, C double bond OH. This is the first propanol, and CH3, CH2, just a second. CH3, CH2, and C double bond OH. This is the second propanol. So what we have to do? Remove oxygen from one aldehyde and remove the alpha hydrogen. So this is the carbonyl carbon, this is the alpha carbon, and these two are the alpha hydrogens. Okay. So you have to remove the alpha hydrogen. Remove the H2O in this manner, and from this what we will get? CH3, CH2, CH, double bond. So you have to connect this carbon to the carbon from which you are removing the hydrogen. That is this carbon. Okay. So this is carbon number 1, this is carbon number 2, this is carbon number 3. Let's take. You have to connect 1, 2, 3. The first carbon of the first ethanol, first carbon of the first ethanol to the second carbon. Okay, second carbon of the second ethanol. And this is the CH3. And to this second carbon, we are having CHO, which is the number 1. Got it? So this is the compound we have got here. So just by doing this, you can get 2 compounds. So we have to get 4 products, right? These are the 2 products, and the remaining 2 products are these 2 are the self-condensation, because these 2 products we are getting from the condensation of same aldehyde. And the secondly, you do the cross aldol. That is, take the first ethanol and try to make it react with the propanol. You will get one product, that is this. Removal of oxygen from propanol and removal of hydrogen from ethanol leads to this product. And the 4th product will be of this combination. That is, taking propanol and removing the hydrogen from ethanol leads to 4th product. Okay. So this is how we prepare 4 different products. Cross aldol doubt? Okay. Okay. So let me take the first combination. Okay. So take this and this. So let me take the CH3, C double bond O, H. So what is this? This is ethanol. This is ethanol. And the second compound should be CH3, CH2, CHO. So what is this? This is propanol. So first what I'm going to do, I'm going to remove the oxygen from ethanol and hydrogen from propanol. Okay. If I do like this, what will I get? I'll get CH3, CH, double bond, C, CH3 and CH1. So this is one of the compound. Got it? And take the same propanol, that is CH3, CH2, C double bond OH. So this is propanol, and try to react it with ethanol, CH3, CHO, ethanol. Okay. So in the second reaction, what I'm going to do, I'm going to remove the oxygen from propanol and the alpha hydrogens from ethanol. 2 alpha hydrogens will be removed. What will be the product? The product will be, I'll write here, it is CH3, CH2, CH, double bond, CH and CHO. Got it? So this is the product we got here. Okay. And the second product you see, for the second combination, I'm getting the fourth product, which is this. Is this clear now? Okay. So these are the four products. The first two are the self-condensation product. Okay. And the second two are the cross-condensation product. So basically, this is called as cross-aldol condensation compounds. Okay. So shall we move on to the next thing? Yes, Antara Sarkar, what? Tell me. You want to say something? You have raised your hand. You have any doubt? Okay, okay, I'll continue with the class. So you have a doubt. So what is your doubt? Just let me know. Tell me your doubt. Just type your doubt in the chat box. Why it cross aldol condensation? That is the name of the reaction, my dear. That is the name of the reaction. Since we are taking two different aldehyde, it is called as cross aldol condensation. Yeah, since it is having two different aldehyde, it is called as cross aldol. If we take same type of aldehyde, it is called as aldol. If you are taking two different aldehydes, that's what I have said, no? Two different aldehydes or ketones is called as cross aldol condensation. Got it? That is the name of the reaction. Is your doubt clear? Got clear? Okay. So in case of cross aldol, self condensation products are formed at in the major quantity. Self condensation products are formed in the major quantity. This is the point you have to note it down. Okay, we are getting four products now. Out of four, two products are formed at the major quantity. Those are self condensation products. Okay. Shall I move on to the next slide? Shall I move on to the next slide? Shall I go for the question? Okay, take this question. Reaction between benzaldehyde and acetophenone in presence of dilute NaOH is known as. What is the name of this reaction? Canizero, cross Canizero, cross aldol and aldol. So Canizero I'm going to discuss. That is the next reaction. So you can find out the answer from these two options. Tell me whether it is cross aldol or aldol. Reaction of benzaldehyde with acetophenone. So what is the formula for benzaldehyde? It is C6H5 C double bond OH. So this is benzaldehyde. And what is the formula for acetophenone? It is C6H5 C double bond O CH3. So this is acetophenone, and this is our benzaldehyde. Okay. So tell me the name of the reaction that occurs for these two in presence of dilute NaOH. Is this aldol or cross aldol? Since we have one aldehyde and one ketone, it is called as cross aldol. Okay. You can take two different, option C is the correct answer. You can take two different aldehydes or you can take two different ketones. Okay. Or you can take one aldehyde and the another one as ketone. Okay. So all these three refers to cross aldol condensation product. Okay. Shall I move on to the next reaction? We have got the answer. Visakhapatnam students have got the correct answer. That is great. I'll move on to the next reaction, which is called as Cannizzaro reaction. So it is again a naming reaction, very important reaction. So this reaction involves aldehydes having no alpha hydrogen. Can any one of you name an aldehyde which doesn't have alpha hydrogen? We do have two different aldehydes, two different main aldehydes which doesn't have alpha hydrogen. Can any one of you give me any of that compound in the chat box? The name of the compound or the formula of that compound? The aldehyde which doesn't have alpha hydrogen. I think the last answer is wrong. Which answer? This answer? No, the answer is correct only. This is the ketone and this is the aldehyde. Ketone contains alpha hydrogen and aldehyde doesn't contain alpha hydrogen. One among the system contains alpha hydrogen, right? So we'll remove oxygen from aldehyde. Yeah, that's what I'm saying now. Listen. One of the two reactant contains alpha hydrogen. So it undergoes cross-aldol. Okay. Only if both the compound doesn't contain alpha hydrogen, then that reaction is called as Cannizzaro. Here one among the two has alpha hydrogen, right? So this is the alpha hydrogen. So we will remove oxygen from benzaldehyde and 2 hydrogen from the acetophenone. And we arrive at a product and that product is the cross-aldol product. Got it? Acetophenone contains alpha hydrogen. Benzaldehyde is not having alpha hydrogen. No problem in it. Okay, fine. Okay, I'll go for the Cannizzaro. In Cannizzaro, both the reactants, we are taking 2 reactants in aldol reactions, right? So both the reactants doesn't contain alpha hydrogen. It is called as Cannizzaro. I asked you to name one of the system aldehyde which doesn't have alpha hydrogen, right? Can you think of it? Okay, let's go. Let's go with the thing. Yeah. Formaldehyde. It is formaldehyde. So you see, this R group is the, formaldehyde. R group is the hydrogen. If R group is hydrogen, then this is called as formaldehyde. This is called as formaldehyde. Or we can, and the IUPAC name is methanol. Since it contains only 1 carbon, it is called as methanol. And we have 2 moles of formaldehyde. That is HCHO and HCHO. One of the aldehyde, alpha carbon is not present and that's why alpha hydrogen is also not present. So Cannizzaro reaction involves aldehyde having no alpha hydrogen. Okay. So among these two, on reaction with NaOH or KOH, we get alcohol and carboxylic acid. That is, one of the aldehyde is getting reduced to alcohol and the another aldehyde is getting oxidized to carboxylic acid. So this is the reduced product. Alcohol is the reduced product and carboxylic acid is the oxidized product. We all know, right? Aldehyde on oxidation forms carboxylic acid. Okay. And aldehyde on reduction forms alcohol. Aldehyde on reduction forms alcohol. So one of the aldehyde is getting reduced to alcohol and the second aldehyde is getting oxidized to carboxylic acid. Okay. So you see here, so what is the formula of the alcohol which we get from the aldehyde? It is 1 carbon containing alcohol. Since the aldehyde is having 1 carbon, so 1 carbon containing alcohol is called as methanol. And 1 carbon containing carboxylic acid is called as methanoic acid. HCOOH. So these two are the products we get from methanol. Okay. Disproportionation reaction. Yeah, disproportionation means the oxidation number of a particular element will get changed. In one of the compound, it gets oxidized, and in the other compound, it gets reduced. But here, it has nothing to do with the oxidation number. Just you remember, in the organic reaction, one of the product is getting oxidized and another one is getting reduced. Okay. What is the oxidation number of carbon in methanol? Oxidation number of carbon in methanol. Oxidation number of this carbon, it is X plus 1, and here also plus 1, minus 2 is 0. So X is equal to 0, right? Oxidation number of carbon in methanol is 0. And in case of methanol, what is the oxidation state? Yeah, X, 4 hydrogen we are having. So plus 4, minus 2 is equal to 0. And X is equal to minus 4 plus 2, it is equal to minus 2. So in case of methanol, sorry, it is minus 2. It is minus 2. Okay. This is minus 2. And what is this here? X, 2 oxygen, so minus 4, 2 hydrogen, so plus 2, which is equal to, I'll write here, sorry, really sorry. Sorry, just a second. There is some issue with my pen tab. Okay, so here the oxidation state of carbon in methanol is 0, and in methanol what we got? We got minus 2, and in case of methanoic acid, what is oxidation state? It is X minus 4 plus 2 equal to 0. So X is equal to 4 minus 2. So it is equal to plus 2. So in this, it is getting oxidized and here it is getting reduced, which is a disproportionation reaction. We have to see for carbon. Okay. Canizero reaction involves different aldehydes having no alpha hydrogen. Then this reaction is called crossed Canizero reaction. Okay, if we are taking two different aldehydes, then it is called as crossed Canizero. That is, if I am taking methanol and benzaldehyde. Benzaldehyde also doesn't contain alpha hydrogen, right? So this is benzaldehyde, a different aldehyde, and this is methanol. Aliphatic and aromatic aldehydes we are taking. So here, benzaldehyde is getting reduced and methanol is getting oxidized. Okay, benzaldehyde is getting reduced and methanol is getting oxidized. Okay, this reaction cannot be called as a disproportionation because two different carbons are undergoing oxidation and reduction, no? So if a same carbon atom undergoes oxidation and reduction, we can call them as disproportionation. But here, benzaldehyde carbon is getting reduced and the methanol carbon is getting oxidized. Okay. So, which aldehyde gets oxidized and which aldehyde gets reduced? Usually, less hindered aldehyde gives the oxidized product. So, less hindered means less crowded. So, in case of methanol, you see this is methanol. And in methanol, we are having hydrogen. In case of benzaldehyde, we have C6H5 group attached to the carbonyl carbon. This is more crowded, right? This is less crowded because of the small hydrogen. So the less crowded group or the less hindered aldehyde is gives the oxidized product. And that's why methanol is getting oxidized. Got it? Do you have any doubt here in this crossed Canizero and Canizero reaction? If you don't have any doubt, just type yes. If you have any doubt, just let me know in the chat box. I'll repeat it again and try to clear your doubt. Yes. Thank you. I'll move on to the next reaction. That is the last reaction, sixth reaction of aldehydes and ketones, which is electrophilic aromatic substitution reaction. This you might have studied in all the organic chemistry lessons. And since we are studying about aldehydes and ketones, I am going to discuss this electrophilic aromatic substitution with an aldehyde group containing aromatic system. That is, we are going to see it for benzaldehyde. Okay, benzaldehyde on treatment with Br2 in presence of FeBr3. So what is the name of this electrophilic aromatic substitution? We do have 5 different types of electrophilic aromatic substitution. Under this 5, this reaction falls under halogenation. This reaction falls under halogenation reaction. So here, these two are the electrophilic reagents, and from this electrophilic reagents, Br plus electrophile will be generated, and that electrophile will go and substitute the meta position of the CHO group. So what is meta position? Alternative position. Alternative position to the C double bond O carbon attached system. Okay. Why we are getting the meta product instead of getting ortho and para? Why we are getting meta product? Since the CHO group is an electron withdrawing group, which is more stable. Meta is more stable. It is more stable, and it is the only product that is being formed because CHO group is the electron withdrawing group. CHO group is the electron withdrawing group. If an electron withdrawing group is attached to the ring, aromatic ring, then the incoming electrophile goes to the meta position. Okay, this is the concept. If the system contains electron donating group, then the electrophile goes to ortho and para position. Okay. So this is about the electrophilic aromatic substitution. Meta position is relatively less electron deficient, hence electrophile prefer for meta position. Okay, less electron deficient in the sense that is the center which is more electron rich. Meta position is the center which is more electron rich. Okay, so an electron deficient electrophile goes and attacks the electron rich center which is meta for benzaldehyde. Got it? Yes. So, we have studied the 6 preparations: nucleophilic addition, oxidation, reduction, aldol, and canisero, and electrophilic aromatic substitution. Now, let's see the uses of aldehydes and ketones for today's class. Aldehydes and ketones are used as solvent, that is in the syrups and all you can see, and it is used in biological specimen preservatives to prepare bakelite. So bakelite, you can see the buttons is made up of bakelite, and in the cooker handle also you can see in the utensils which we are using at home, those are bakelites. They are made up of aldehydes and ketones, and the urea formaldehyde glues also contains aldehydes. Okay. These are the uses of aldehydes, and some more things are there. And aldehyde, acetaldehyde is primarily used as a starting material in the manufacture of several compounds. What is the formula for acetaldehyde? It is CH3. It is CH3CHO, right? This compound, it is used to prepare acetic acid, which of formula CH3COOH, and it is used to prepare ethyl acetate, that is OR bond. OR group is getting attached, OH bond is introduced, and OR bond is introduced, and it is used to prepare vinyl acetate. Vinyl acetate, CH2 double bond, CH bond. This group is called as vinyl. Okay, so here you can see that group, CH2 double bond, CH. So vinyl acetate can be prepared using acetaldehyde, and some polymers are prepared. And at last, drugs, all the tablets, drugs, they are also getting prepared from acetaldehyde. Okay. So acetaldehyde is the main aldehyde which is used to prepare for those five. And benzaldehyde is used in perfumes. Since benzaldehyde is an aromatic compound, it is used in perfumery industries and in dye industries also. They are using the benzaldehyde component for dyeing purpose. And many aldehydes and ketones like butyraldehyde, vanillin, acetophenone, camphor, they are well known for their odors and flavors. They are the sweet smelling compounds and they are used in all the flavoring agents. Okay. This is about the uses of aldehydes and ketones. And let me just summarize the class, today's class. So we have started the class with iodoform reaction. In the iodoform, what we have studied? CH3 group was converted to ONA group with the release of CHI3, that is iodoform, as an yellow precipitate. And then we have seen algal condensation, and thirdly, Canizero, where one product gets oxidized and the other compound gets reduced, and at last aromatic substitution reaction. Halogenation we have discussed. Okay. So do you have any doubts here in the aldehydes and ketones part from today's class? If you don't have any doubt, I can start the carboxylic acid for today, and I'll just do some, no, ma'am, is for which question? No doubt. Okay, thank you so much. So I'll start with the carboxylic acid and continue this carboxylic acid in the next class. Okay. So moving on to carboxylic acid and its preparation. So today we are going to see, I'm going to start with the preparation of carboxylic acids. Okay. So what is the formula for carboxylic acid? Carboxylic acid is C double bond O OH. So COOH containing compounds are called as. Please give some mild oxidizing agent for which reaction you are asking? For which reaction? For the preparation of carboxylic acid? Or generally you are asking me the mild oxidizing agents? Okay, I'll give you a list of mild oxidizing agent and strong oxidizing agent. Mild oxidizing agent and strong oxidizing agent list I'll give you. So mild oxidizing agents are PCC. What is PCC? Pyridinium chlorochromate. And PDC. PDC is pyridinium dichromate. Okay. And then copper at 573 Kelvin. So all these three reagents fall under mild oxidizing agent. That is, it will oxidize the alcohol to aldehyde. It will not undergo further oxidation of carboxylic acid. Alcohols will be, all the alcohols, primary or secondary or tertiary, those alcohols will get converted to aldehyde. Aldehyde will not undergo further oxidation to carboxylic acid if we are using mild oxidation here, oxidizing agents here. Okay. And the strong oxidizing agents are K2Cr2O7, that is potassium dichromate, and KMNO4, that is potassium permanganate in acidic condition. Okay, in acidic condition. And then Jones reagent you can use. What is Jones reagent? It is CrO3 and H2SO4. This is called as Jones reagent. So, Jones reagent. So, these three are the main strong oxidizing agents. Got it? So, these strong oxidizing agent can straight away convert the alcohols to the corresponding carboxylic acid instead of going through the second step, that is the aldehyde and ketone step. It can straight away convert the alcohol to aldehydes, carboxylic acids. Okay. Visakhapatnam students, are you okay with this? Okay, fine. So let me go for the preparation of carboxylic acid. I just discuss only one preparation today and continue with the remaining in the next class. Okay. So from primary alcohols and aldehydes. Only one student. Okay, okay. You can mention your name, no, as your ID. Okay, 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 no problem. So KMNO4 with in basic medium, K2Cr2O7 in acidic medium, and the CrO3 in acidic medium. So all these reagents are used to convert the primary alcohol to carboxylic acid. Just now I have discussed, no, any one of these agents can be used to convert, or it is used for the preparation of carboxylic acid. So from alcohol to prepare carboxylic acid, we are using potassium permanganate, and from aldehyde, we are using potassium dichromate, and to convert alcohol to acid, you can use two-step. Okay, this is an example where R group is the methyl group. So ethanol on oxidation forms ethanal, then ethanal on oxidation forms ethanoic acid. Okay. Carboxylic acids are also prepared from aldehydes by the use of mild oxidizing agents like Tollens reagent or Fellings solution. So in Tollens reagent, what we have used? We have used ammoniacal silver nitrate solution, right? And in Fellings solution, we have used copper solution. So those two reagents are again a mild oxidizing agent. Copper ion containing system and the silver ion containing system. So from that, you can use carboxylic acid from aldehydes. That is here in place of K2Cr2O7, you can use Tollens reagent or Fellings solution. Got it? That Tollens contains Ag plus ion and the Fellings solution contains copper 2 plus ion. Okay. Then from alkyl benzene, second preparation, I'll discuss in the next class. So do you have any doubt here in the first preparation of carboxylic acids from alcohols and aldehydes? If you have any doubt, just let me know, or else I'll close the class. You can continue this in the next class. Students, do you have any doubt? No doubt? Thank you so much. Take care. So meet you all on Thursday. Okay. Thank you. Thank you so much.